So given that you had come from this position of skepticism, like you were sure that these weren't planets, how did you feel when he sent you the data from the plane and you're on vacation and he's like, they're moving with the star and they're orbiting? Like, was it just mind blowing?
No, it was still pessimism, honestly. So
Have you ever wondered what it's like to discover a brand new world? In the last 3 decades, we've found over 5,000 planets outside our solar system, called exoplanets. I'm Dr. Jessie Christensen, the lead scientist at the NASA Exoplanet Archive. This is Explore Exoplanets, The Discoverers, a series where I interview the brilliant minds behind the discovery of brand new planets.
Hello, everyone. If you're watching this on YouTube, you can also listen to this as a podcast. Head to Apple Podcasts or Google Play and take us with you on your morning commute. If you're listening to us, you can also watch us on YouTube, where you'll find some bonus graphics to help explain what my guest and I are talking about. Speaking of which, welcome. We are joined today by Dr. Bruce Macintosh, who's the director of the University of California Observatories. Hi, Bruce.
Hey, Jessie.
Thanks so much for being on the show. I know how busy you are. Where are you physically located right now?
I'm physically at University of California, Santa Cruz, which is kind of the headquarters for University of California Observatories, in my nice office.
Do you get to visit all of the UCs, though? How many are there? I should know.
There are 10, one of which doesn't count for my purposes because UC San Francisco just has a med school, and I'm unaware of any astronomers there, though if some want to move, it's probably a growth opportunity. And I've been visiting all the campuses in order and developing theories about their architecture as kind of a hobby.
I see. So you do get to get around.
Yeah.
So you're the director now. Tell us a little bit about what that means and how you got there in your career.
What it means right now is we're responsible for running the telescope facilities that University of California astronomers get to use. So we directly run Lick Observatory near Mount Hamilton and do a huge amount of public education and outreach, and people should come visit us there. We represent University of California in the collaboration that runs the Keck telescope, which is where I've done a lot of my science over the years, and most of our people do our flagship science. We build new cameras and spectrographs. And then I go to a lot of Zoom meetings and listen to people asking why they're not getting enough telescope time.
There's never enough.
Doing this, I'm relatively late in my career. I've discovered planets. I'll get to talk about that. I've built big instruments. I'll get to talk about that. I was at a point where what I wanted to do instead was kind of help the next generation in everything from building their cameras and spectrographs to thinking about ways to make astronomy a better place.
Have you always been in North America during your career? Did you ever leave? Have all your positions been around here?
Grew up in Canada, but I've been in California for my whole professional astronomy career, starting at UCLA.
Oh, wow.
The largest project I did was went on a telescope in Chile. So I spent a lot of time going down to the Gemini Observatory in Chile to deploy and do observations and things like that.
Okay. Well, let's talk more about that, the instruments and the planets and everything. Tell us how you discovered the planet that you found. Tell us about your planet.
Okay. So it'll actually be 3 or 4 planets because we discovered them all at once very efficiently. So I do something called direct imaging. So you've heard in different previous podcasts about the way planets are studied with transits or with Doppler techniques, which are kind of the easy ways to find planets, honestly. Direct imaging is when you actually get to see the planet as a little dot next to the star. And it's hard because stars are about 1 billion times brighter than planets. The analogy we're required to use by astronomer law is it's like there's a lighthouse and you're looking for a firefly right next to it from miles and miles and miles away. So you've got to really work really hard to block out the light from the lighthouse so you can see the tiny little planet, little bit of light peeping around the edges. It's a potentially powerful technique. It can see very different planets than the other ones, but it's really hard. The kind of planets that it's sensitive to are planets a long way away from their star instead of close. Those actually turn out to be rare in the universe. With the technology we have right now, we actually can't do the 1 billion to 1. Instead, we have to look for giant, young, warm planets that are only 1 million times fainter than their star by comparison.
Right. So easy.
Easy, yeah. So I was one of the groups that started doing this. We use the largest telescopes on the planet, like the Keck Observatory. We use adaptive optics that corrects for turbulence in the Earth's atmosphere. We look where we think these planets are still likely to occur. And then for a long time, we just utterly failed to find them. If you're looking at a star and you see a little tiny faint thing next to it, you might, the first time you see it, like I did, get excited and say, oh, we've discovered a planet. But really, you've discovered another star that's just far away and looks faint.
Right.
And then you come back and look at it a year later and they've gone off in different directions. So you look at another star, little faint thing, planet, star, background star. Little faint thing, is it a planet? Background star.
Right.
Did about 8 years of this. We stopped counting around 200 background stars. But you keep doing it and you keep improving the techniques. We figured out ways to get more sensitive and so on. And I did this in collaboration with a brilliant Canadian astronomer named Christian Merois, who sort of took over the data analysis and the kind of leadership. And he kept doing it. He looked at one of the stars and he said, oh, I found another little candidate thing. It's probably a planet. I tried not to be depressing and say.
I was going to say, did you just start to get really, cynical at some point? Like,
oh yeah, no, long before this, but you don't do it in front of the young scientists if you can avoid it.
Right.
And then he said, actually, well, we've discovered two things next to it. And I said, okay, there's no chance we've discovered two planets. They have to be background stars. And in fact, I said, this is Macintosh's law. Anytime you find two things, you're never going to get so lucky as to find two planets. They absolutely have to be background objects.
Okay.
In hindsight, that's the single most scientifically wrong thing I've said in my life. And you can think about the math and understand reasons why, even with the benefit of foresight, it should have been obviously wrong, but I was forceful. But nonetheless, you go and do the follow-up observations.
Right.
And so we actually got assigned telescope time at kind of the last minute when something else was canceled. I was on vacation, and so Christian got to go to the telescope by himself.
Right.
And he did the observations.
Was this at Keck?
This was at Keck, yeah. So he got to go out and do the observations and then was literally reducing data on the airplane backwards and called me in the mountains and said...
Right. So for folks at home, Keck is in Hawaii, so it's not a terrible thing to have to rush to Hawaii at the last minute to get your data.
There are worse places to end up being. And then he said, turns out they're actually following the star and they're orbiting around it. And I didn't believe him at all. And then as he dug deeper, he actually said, there's three of them. And again, what are the odds we'll find three? But we did what we were supposed to. We did all the analysis very carefully. We worked to understand if they looked like planets we're supposed to, which they sort of didn't. And so we had to understand what was wrong with the models to make them look planety. And we did due diligence. And then turns out to be real. It was the first system. There's a lot of argument about what the first exoplanet was that was directly imaged. This is clearly the first system. We like to say it's the first case where there were three at one. And now...
and which system is it? Tell us the telephone number.
The serial number is HR 8799.
It's amazing. It's a gorgeous, gorgeous system. The movies we have are just unprecedented and so pretty to look at.
Yeah, the fact that now we've got 15 years of this data. You'll see the animation by Jason Wang. We watch the planets move and they obey Kepler's laws. And it's not a surprise that they obey Kepler's laws. Those are kind of usual. But we see Kepler's laws in real time from outside and watch the planets moving like clock hands.
It's really, really very pretty. So given that you had come from this position of skepticism, like you were sure that these weren't planets, how did you feel when he sent you the data from the plane and you're on vacation and he's like, they're moving with the star and they're orbiting? Like, was it just mind-blowing?
No, it was still pessimism, honestly. So it took a long time to really think that the evidence was correct, and then excited, and then thinking this is complicated, and how will we understand them? And
so when were you convinced? What was the piece of information where you were like, finally, like, yes, okay, these are planets?
The two parts, I think, when he actually saw not just were they moving with the star, but they were orbiting, and they were orbiting in the same direction, which is what planets should do. No reason for background objects to especially do that. And then when another one of our collaborators, Travis Barman, managed to adjust planet models so that they could reproduce the brightness of the objects very precisely, and then turn that into understanding. The pictures all started
to come together and you're like, this makes sense.
There are multiple lines of evidence consistent with planetiness. And then there were still other people who said, no, they're not planets. So it took a while to settle down. But
right. Well, I mean, HR 8799 was one of these first systems where, and the planets are so big and they're so hot. And, I could believe that people for a little while were like, yeah, but are they really solar system like, or how different are they? And, how big and hot can something get and still just be a planet? And I can understand that people took a while. So how many planets have you been involved in discovering in total? Do you know?
Only 5. Direct imaging has the, they're bespoke planets. We do them as individuals rather than assembly lines. So 5 planets and some number of brown dwarfs, the 4HR 799, and then another direct image planet called 51 Area B, and then a bunch of brown dwarfs and observations of other systems.
Okay. So out of those 5, or you could extend it to all of the existing planets, do you have a favorite real planet?
Probably would go for 51 Area B, 51 Eridani B. So that we discovered with the telescope I mentioned in Chile, where we built a dedicated planet imager. And it's the coolest in a literal sense of the directly imaged planets, which is to say it's only like 600 Kelvin or so. Right. And it looks like Jupiter. Like if you showed the spectrum to an astronomer 100 years ago and said, close your eyes, what is this? They would say, that's a planet. It's got these big methane absorption features. It's got all the stuff that planets were supposed to have that were kind of hard to find in the
How
early
far
ones.
away from its star is it? Is it in a Jupiter-like orbit as well?
A little bit further, but not. It's more sort of Saturn-like orbit, so sort of 15 AU, but still more solar system-like.
So out of directly imaged planets, is it still the closest analog to our solar system that we found?
I would tend to say so, although there's tentative evidence its orbit is weirdly elliptical, which is different than our solar system. But it's certainly physically the most Jupiter-like of all the planets that we've seen.
That's very cool. And have we been able to make movies of it the way we have for HR 8799?
There's a movie because there's only one, and because it doesn't have as long a baseline, it's not as exciting. And unfortunately, it's moving closer to the star, so it's getting harder and harder and harder to see.
Right.
Just in partially because of the way its orbit is tilted, and partially because its orbit is really elliptical. So it's not as spectacular. But again, if you go to Jason Wang's webpage or possibly linked into this video, there's a nice movie of a little bit of an arc of it going along.
Right. So that gets to something interesting about direct imaging. So we've talked about the fact that you're literally just looking for the light from the planet. But given the orbit of the planet, sometimes you won't see it. Like it'll be behind the star or directly in front of the star or just too close to the star. So that must hurt your statistics as well when you're looking at hundreds of stars trying to find planets and you just know that there will be some fraction of them you can't see.
A little bit, but again, compared to my colleagues who do transits, it's like 100 times more likely. So yeah, it's frustrating, especially frustrating when you know the damn thing's there and it's going to go behind the star. But there's another system, Beta Pictoris, where it's actually been watched, started on this side, went boop, almost behind the star, nobody could see it, popped out on the other side. We observed it for a while, boop, went behind it again, and now it's popped out on the far side. So if you're patient, they'll show up eventually.
Right. So typically at this point, I would ask you what your favorite fictional planet is. But as we've established, you bring some cynicism and snark to this. So I'm going to ask you instead, what is your least favorite fictional planet?
Okay. The planet I picked as my least favorite is Kepler 22b, and not for any personal reasons, but more for sort of philosophical reasons and about how we discover planets. Nothing against it as an individual or the series it appeared in, which is great, but the way we think about which planets we're actually going to go to.
Okay, so let's get more into that next episode. In the meantime, please follow us on Instagram, Facebook, and Twitter. And wherever you're enjoying this, please like and subscribe or rate and leave a review. And so join us coming up next. We're going to find out more about Bruce's least favorite fictional planet and its real-world counterpart. Thanks, everyone.